Welcome to this tutorial. Launch Infero in your browser, then download the sample dataset. Upload the sample dataset and map the weight and observed columns. This is a simple frequency model, so we select the Poisson distribution. Switch to full screen and try the search bar. You'll also notice a ticked-only filter. Next, we add the gender to the model and fit it. The graph is now populated with conditional effect and fitted racial lines. We then add a variate for driver age to capture the decreasing trend in claim frequency with respect to driver age. We also add an interaction between age and gender, a classic example where young males show a higher claim frequency. We set the current model as the reference, and we see that the reference fitted line does not capture the increasing claim frequency with respect to the no-claim discount variable. To address this, we add a variate to capture the missing trend. Now the no-claim discount variable is perfectly captured. We deleted the reference model, and we now try adding a meaningful grouping to the zoning variable. We fit the simple factor and order the levels of the zoning variable by conditional effect. Next, we create a grouping composed of 3 groups using the word grouping feature. We fit the ordered variable and click the standard error on a difference button. Then we select as the reference group the one composed of 3 groups. However, we see that 85 times we reject the hypothesis of equality between coefficients within the same group. The data suggests the existence of an underlying set of 4 groups. However, we will now try with 5 groups to uncover another type of common issue. By setting a grouping made of 5 groups, another issue arises. We now see a misclassification rate of 9%, which is the opposite problem. The distinction between the levels of Group 2 and Group 3 seems to be driven by chance rather than by an actual underlying statistical law. There is not enough statistical evidence to reject the hypothesis that the coefficients of Group 2 and 3 are different. So we select a grouping made of 4 groups, and we see that both issues are resolved. We can visualize this graphically by using the reference model. The 4-group model perfectly encompasses the simple factor model. Finally, we can download the PMML model as well as the model specification. We delete all variables and test the model adapter feature by uploading the previously saved model specification. The previous model is restored successfully. We can then refit the model, and finally, we test the model offset feature. Thank you for watching.